only works on right triangles. So let's start with that in your notes. Okay, this theorem I'm about to show you, put a star, only works on right triangles. So if we go back, I'm gonna get to my putting up my barn problem. When I measured this diagonal over here, that was telling me if this corner turns out to be a 90-degree angle, which means square. Are you with me? Then when I measured the other angle over here, and it turned out to be the same exact distance, that told Mr. Murphree that that corner of the barn is also a 90-degree angle, which means it is square, or some builders call it plumb. Are you with me? Plumb is another word for square. So if you ever hear a builder like, that wall is not plumb, that means that wall is leaning. It's not square. It's not square to the floor. Are you with it? My grandfather, he's an old builder. He came over during Thanksgiving while we're putting up the barn. Guess what the first thing he did to us? He grabbed the tape measure and he measured from this corner to this corner. And I'd already measured, so I knew it was the same. And then he walked from this corner to this corner and he looked at me and he goes, that'll work. That was his way of saying, good job, boy. Of course, he's from World War II era, so like, he was looking to give me a hard time because he loves giving me a hard time if I mess something up. All right, so any questions so far? Well, here's the theorem. A squared plus b squared must equal c squared. So that is Pythagorean's famous theorem. And let's talk about what it means and how to apply it to a problem with a right triangle. So if we have a right triangle, one of the corners of the triangle, it has to be a 90. Do y'all agree? Okay, the 90, do you see the little box in the corner? It always touches the two legs of the right triangle. So this side is a leg, this side over here is a leg. The 90-degree box in the corner does not touch one side. It doesn't touch this long side over here. Are you with it? We have a big fancy name for that. It is called the hypotenuse. That's a weird word. Hypotenuse. All right, got a math joke. What do you call a restroom in an airplane that is occupied? Any question or any answers? What do you call a restroom in an airplane that is occupied? Y'all aren't picking up what I'm putting down. The answer is high pot in use. Thank you, Summer. I'll take that giggle as a victory. Think about that for a minute. Zach is like, oh my gosh. It's math, Zach. We don't have funny jokes for math. Just deal with it. Now, here's the nice thing about the formula from Pythagoras that Pythagoras figured out thousands of years ago. This side right here, C, is always the most important. It is always the hypotenuse. A and B are the legs. It really doesn't matter which one you call A, which one you call B. But these two legs are the A and the B for the triangle. Ooh, let's make that a better A. A and B. If you want to be a rebel bottom, you can call that B and that A, and you will still get the same correct answer. They're interchangeable. This is the only side you cannot screw up. That side has to be C. Here's a little way to remember which one's C. Do you see the little 90-degree corner? It always points towards C. The corner points towards what side is C. Right away. All right, so here's what Pythagorean's theorem really says. If we take this side of the triangle and square it, that means make a square that is A long and A wide. If we take B and square it, which is B times B, and add those two areas together, they will always add up to the big side squared, C times C. So Pythagoras figured out that if we have a right triangle and we square this side, make a square, A times A, and make a square, B times B, and add A squared and B squared together, these two areas, it will always be the exact same area as the big one squared. Are you with me? Now, let's look at a couple and let's prove it. And I'm going to use the picture and the formula. All right, one of the most famous right triangles is called the 3, 4, 5. Are you with me? A is 3, B is 4, C is 5. Let's do the math. What's 3 squared? 9. What's 4 squared? 16. What's 5 squared? 25. What's 9 plus 16? 25. So, if I have a triangle that has 4 on this side, 5 on this side, 3, 4, 5, Murphree. 3 on this side, 4 on this side, and 5 on this side. If we do the math, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. If I add these two numbers together, they do add up to the big number 25. 9 plus 16 is 25. That is all Pythagorean's theorem states right there. This square plus this square has to add up to that square. That's why we have to put the little 2 or the square symbol in each piece. Are you with me? Now, that becomes in handy when we have a problem like this. They give me 2 sides of a right triangle. Whoa. I'll do the box in a minute. And they want me to find one of the third. Let's say this is 8 and this is 10. If they give me those two numbers, I can instantly plug them into the formula and find out what the other missing number is. By the way, what side are we missing? Are we missing A, B, or C?
C.
C. Good. Remember, C is always opposite the 90. So we're going to find out what C is. So let's plug in the numbers. Let's call A 8. We'll call B 10. And we are about to find out what C is. All right, what's 8 squared? 64. Plus, what's 10 squared?
100.
And let's add those together. What's 100 plus 64? You need to be writing these down, Zach. I don't know why your pencil's not moving. That's 164. So, is this third side going to be 164? That seems awful big for that triangle, doesn't it? What have we found so far?
C.
We found that C squared is 164. We want to find out what C is, not what the big square is. Are you with me? Right now, we have the area of the big square. We don't want that. We want to find out how long is this little side here. So what can I do? What's the opposite of squaring?
Dividing.
Nope, dividing is the opposite of multiplying. Try again. What's the opposite of squaring? Square root. Very good lip readers around here. So watch. To get rid of C squared, you take the square root of it. We need to take the square root of both sides. So the square root of C squared is C. What's the square root of 164? Type it into your calculator, please. There is a little square root button on there. So you just hit the little square root button. Now, The square root button is right there in blue. So hit blue, x squared, 164. And it turns out to be a decimal. What do we get? 12.806. For today, let's just use 12.8. I'm not too worried about all the decimals today. Questions? Raise your hand if you couldn't find the square root button. All right, Isaiah, look at this button that says X2 on it. You got it? Right above it in blue is the square root symbol. So you're going to have to hit the blue button and X squared button. And that will pull up the square root on your calculator. Got it? Let's do another one. What if they give me, I'm good?
I think so.
Thank you.
After this.
What if they give me these two numbers and they want me to find this missing side? So, do they give me C? Yes. What number is C? 30. So we're going to go ahead and plug in 30 squared. Do they give me A? Nope. So we'll just leave that A squared. Do they give me B? Yep. 24 squared here. Calculator time. What is 24 squared? It's a pretty big number. $576. Thank you. What is 30 squared? It's an even bigger number. 30 times 30. 900. And to solve this equation, what do I do? Somebody tell me how we can solve this equation. We need to find out what A squared is. Are we going to add these two numbers together? We're going to have to subtract this one from 900 first. So, subtract 576 from both sides. Calculator time. What is 900 minus 576? 324. And we now have A squared is 324. Do we want A squared? No. How do we get rid of the square? Square root, both sides. What's the square root of 324? 18. Turned out to be a whole number this time. Question. So this little leg of this right triangle must be 18 for Pythagorean's theorem to work. Are there any questions? So on the homework, they're going to give you two of the three sides of the triangle. You're going to have to use Pythagorean's theorem to find the missing side. Okay, you're always going to take the square root at the very end. Are you with me? Once you get A squared by itself. Here, we had to subtract 576 before we could square root. All right, my advice, if you get a decimal, just give me the first number. Like that first example, we get 12.806. Let's just use 0.8, 12.8. You're going to get quite a few decimals today.